first C program. So I hope everyone's ready for this. Can we have some messages in the chat if you're ready for diving deep into this world of C? Okay, cool. So first of all, let's start off with this. What is programming? So basically, a program is a set of instructions that the computer can execute to perform a specific task. So everything inside a that's happening in a computer is basically a program. The games that you play, or the browser application that you are using right now, or some other application like some any application, that can be a program. And not only that, the basic operating system, that is also a program. So everything in a computer system is actually a program, and it's basically a set of instructions that tells the computer hardware, our CPU and memory and all, about what to do next. So when these instructions execute, the CPU can perform certain tasks and accomplish certain goals that we need to achieve. And programming is a way to instruct the computer to on how to perform these tasks. So there are various programming languages. We'll get to that later on. Yeah, so this is basically what programming means, and everything in a computer system is basically a program. So we'll dive right into the things called algorithms and flowcharts. So does anyone here have a previous experience in coding, be it in any language or up to any level, doesn't matter? Does anybody have previous experience in coding and all? Can we please tell it in the chat? It's okay if you don't have it. This is meant to be a beginner friendly program. So please do tell me if anyone has previous experience. Yeah, in C++, good. So yeah, so a lot of people have it. So that's good to have. So even if you don't know, I'll start from the basics. So basically, we have two ways to represent our program's idea to someone else. So there are the two ways are, one is using an algorithm and one is using a flowchart. So what's the difference between the two? Sometimes you might have heard of it. If anyone has heard about it, please do tell me in the chat whether you have used algorithms and flowcharts before, or any experience of that sort. Please do tell me. Basically, an algorithm is basically a step-by-step definition of how to work on a problem. That is, it's a set of rules or instructions that we need to carry out in a step-by-step manner so that our goal is achieved, or our problem is solved, so that our problem gets solved. So if I ask someone, how do you make tea, or how do you make some biryani or something, some food item, they'll give you a step-by-step way on how to do that thing, right? So first of all, you need to take this, then add this to that. In that kind of a way, people will explain how to make something. So in a similar way, algorithm is a similar step-by-step instructions so that we can achieve a goal. So algorithms are very important. We'll be using it throughout our career. Basically, when we get a problem, we first try to find a suitable algorithm for it, and then only move on to the coding part. So writing an algorithm is really important, and it's a step-by-step instruction set that we can convert into a code. So then what's a flowchart? So flowchart is something a little bit different, but it conveys the same idea to the end user. So in an algorithm, there's a uh, step-by-step set of instructions that gets executed one by one. But in a flowchart, it's actually a graphical representation. So what that means is that there will be sort of like many we'll draw boxes and all, and we can actually show the flow in which our program will execute. So this is actually a really easy thing to understand, these flowcharts, because they are graphical in nature, and we can actually understand it quite easily, because we can see the way in which the flow goes, right? So there will be sort of like some instructions and all, and we'll be relating them with using arrows and all. We'll be talking about that later on in this video, in this meet. So flowchart is a graphical representation of the algorithm. That's basically what it means. And algorithms are usually a little bit more to the point. So they are they can be, they are suited for some high level things. Like sometimes you might need to convey your idea to some other programmer and all, then this algorithm can be really helpful. Whereas a flowchart is can be used when you need to convey an information, just give a general overview to someone, or when you want to show this to someone who doesn't really understand about coding but needs to know how this solution works. So in that case, flowchart can be really helpful, and algorithm is a bit more suited when we actually know what coding is and how it works. So is everybody clear with this? If you have any doubts, please do tell it in the chats. Are we clear so far? Hello? No response? Yeah, so far clear. Okay. Okay. So we'll move on to the next part. So basically, I need to show you some differences between an algorithm and a flowchart. So first of all, like I said in the definition, algorithm is a step-by-step procedure to solve a problem. So and a flowchart is a diagram, or it's like a graphical thing that can show the flow of data. So similarly, algorithm is somewhat harder to understand. It's because we actually use some concepts that are used in programming languages and all. So sometimes it can be a little bit complex to understand for someone who doesn't know about programming or anything. But a flowchart is really easy to understand. Even someone who doesn't have any previous background in coding can understand what the idea conveyed by a flowchart is. So flowcharts are really useful in those kind of situations. And in algorithms, actually we use plain English text. So we just write how the steps in simple manner. But we may use coding, some of the coding concepts, or some of the words that are used in coding, so that the algorithm can be having a bit more clarity to the person who is reading the algorithm. So it's a bit more concise way, and it's really really helpful while coding. We use it in plain text, so most people who have a background in coding can easily understand what an algorithm is. And in a flowchart, we use symbols and shapes. So there are different symbols and shapes used in flowcharts, and there are certain rules that need to be followed while using these symbols and shapes. And so since we are using these kinds of things, it's much more easier for a novice to understand what the flowchart is conveying. And this thing, algorithm is also called a pseudocode. So what does a pseudocode mean? So uh, like I said, as we all know, we need a language for running our program, right? So we actually code using a certain programming language. And what it means by pseudocode is that its algorithm is actually kind of like a code, but not actually the code. So we can't actually type in the algorithm and tell a computer to run it. We need to implement it using a programming language of our choice. But in order to implement that, we need a basic idea of what this task is, and for that we are using algorithms. And these algorithms can be easily converted to codes, because we can actually use some of the coding related words or concepts in an algorithm that can be helpful while we are converting it into a code. So that's why it is said that it is easy to debug. What does debugging mean? So basically, debugging means when you write a certain piece of code, sometimes there can be errors in the code, so that due to these errors we get unexpected results, or sometimes the program doesn't work at all. So these are called bugs. These errors are called bugs. So we need to whenever we encounter a bug, we need to somehow find a solution and try to debug the problem. So when we are using an algorithm, it's actually easier to debug. You'll understand it clearly once you use an algorithm for doing a problem. But basically, what it allows you to do is, since you are using these coding concepts inside algorithms, we can actually easily find out whether, oh, this is not how it's supposed to be. It's supposed to be like this. So we need to change it to this way or the other way. We can easily understand that in case of an algorithm. But in the case of a flowchart, it's just a graphical representation. So it doesn't really show the exact way in which the solution is implemented. In an algorithm, we know the exact way in which the solution gets implemented using concepts from programming languages and all. So it's easier to understand if we have made a mistake in the algorithm. But in a flowchart, we just give a rough idea about the solution. And so it's really hard to debug using a flowchart. So whenever we are coding, we usually go for an algorithm, so that we can easily do debugging and all. And also it is easier to convey it to another programmer, or people who have background in coding using an algorithm. But flowcharts are really helpful when we use them to people to show our solution to people who have no experience in coding. So is that clear, the differences between algorithms and flowcharts? If you have any doubts, please do ask me. It's a really important topic, this one. So if you don't have any doubts or anything, we can move on to the next topic. Are we clear? Yes. Okay, so let's just actually see an example of an algorithm. So basically, I told you, algorithm has this step-by-step way in which we represent an algorithm, right? So right now, don't try to understand what this means or anything. This is just for an example. Don't try to think that, oh, this is so complex, I don't understand any line of this text that this guy has put up in this slide. Don't think like that. This is just for an example. This is just to show you the structure of an algorithm. Basically, we start from something, we do the processes that are required in a step-by-step fashion. So each step is executed, and then we move on to the next step, and then to the next, and then to the next, and finally, when we get the required result, we'll stop it. That's how an algorithm is written. So you can think of this as writing down the steps to shut down your computer or something. We have learned that in our school days, right? So click the start button and then click the shutdown button. So things like that. In a similar way, we are writing an algorithm. So we need things that we need to remember is that we need to give these numbers so that we can keep it in a really good step-by-step manner, and we start from what we need, what the problem is, and we get to the solution. And usually we actually either print the solution or give it to something else, so that we can use that solution for some process, or we can actually print it to the screen, we can display it to the screen, or anything like that. It can be anything. Once that problem is solved, we use that result in a way that we intend to use it, and then we stop. That's the algorithm. Don't try to understand what this text I have written in here is. It will be clear to you once you learn more about the programming languages and C. So this is the basic structure of an algorithm. Next, this is how a flowchart is drawn. So in a flowchart, we'll have, like I already told you, we'll use a set of symbols and some text inside those symbols. So here, this is in a way, this looks much easier to understand than this, right? So in this one, we don't understand what an ARR, or what do you mean by compare one by one, or anything like that. We can't really understand it so easily. But in this one, it's much easier. We just start from here. Okay, then we need to input a number from the user, then we need to input another number. So things like that are easily understandable, right? So here, if the first number is greater than the second number, then if that condition results to be true, then we display the first number. Otherwise, we will display the second number, and then we stop. So this is a really easy thing to understand. Even a person who doesn't have a background in computer science or programming can easily understand this. Whereas this one, you need to understand what all of these mean, right? So what's the leftmost element of ARR? What is an ARR? Or what do you mean by one comparison? Or anything like, so things like that are harder to understand. That's why we say algorithms are harder to understand but easier to debug. Since if this wasn't supposed to be the leftmost element, maybe it was the middle element or something like that, we can easily understand, oh, this is where I made the mistake, so this is where I need to change. And hence, in that regard, algorithms are easier. But in the case of a flowchart, we can't really understand if something has gone wrong. It's a bit more difficult to understand what has gone wrong. But on the other hand, it's really easy to understand what a flowchart is trying to convey. So basically, this is the structure of a flowchart. We can have it much longer than this, and we'll be discussing what these symbols mean a little later. So are we clear with what we have seen so far? Are you able to understand how the structure of a algorithm looks, or how the structure of a flowchart looks? Please do tell me in the chat. If there's any doubt or confusion, please do tell me. So let's see how many of you are actually listening to our class. So I'm going to post a link inside this chat box. It's for a quiz that you can attend. Please do try to attend, everyone. It's a really simple question, nothing too serious. You can easily figure it out. So I'll just post it. Just a second. So go to this link and just give a answer to this poll. It's just one question and two options. You need to select the correct option. Please start polling this. I'll wait for a couple of minutes. Everyone do try to attend this poll. It's just to make this session interactive. And once you have done, please chat yes or something in the chat box so that I can know how many people have actually. Yeah. Okay, so about 45 people have polled so far. Okay, so really good response. Almost all of you got the right answer. I'm really happy about it. So I know that you have been listening. So yeah, so let's move on. Okay, so the next thing is, what do these symbols in flowcharts mean? Okay, so we have already seen how a flowchart looks like, but we didn't understand what this diamond shape means, or what this what this parallelogram means, or what this oval shape means. But you can't just use any symbol anywhere and put some text in it and call it a flowchart. There are a set of rules that you need to follow so that you can call it as a flowchart. So here these are basically the some of the most fundamental symbols that are used in flowcharts. So the first one is this oval shaped box. It's used for a start or an end. So if you just see in this one, we started with an oval box and we stopped with an oval box. So basically in every flowchart there needs to be a start and there needs to be a stop. It's compulsory to have a start and stop so that we know where the execution starts and where it ends. So this is compulsory, and we enclose the start and stop text using this oval bracket. And then there are these arrows. So we have different arrows in here, right? So this is an arrow, this is an arrow. So actually we begin from the start, and then we go with the flow. That is, we go through these arrows. So each box or each symbol in this flowchart has been connected with arrows. So we know what the flow is. So if we look at this, we start here, then we go to this one, then with this one, then we check what the condition is here. We'll get to what this diamond box means right now. So then we go here or here, and then go and then eventually we will reach stop. So we know that definitely there's a flow, and always if we start, we must reach a stop. That's important and necessary thing in a flowchart. We start from this beginning thing, and we should definitely reach the stop. So we should structure the flowchart in such a way that the arrows eventually reach stop. So that's one thing. Then we have this parallelogram. So here we have used 4 parallelograms in this one. So parallelograms are used for input and output. So basically what that means is in our program we can actually input some things from the user, or display our result to the screen or to a printer or anyway. So those kinds of input and output operations are enclosed inside these parallelograms. So here we are inputting num1. So don't worry about what num1 is right now. Just understand that we are inputting a number, and so we are enclosing it inside a parallelogram. Here num2, so we are enclosing it in a parallelogram again. And then after doing some calculations that we need, we have decided to print something onto the screen or display something onto the screen so that the user can get the output, or what's the result of that program. So for that we have used this parallelogram again so that we can display the number required. So that's what these parallelograms mean. Then we have these rectangles, rectangle boxes. We haven't used any rectangle boxes in these, but these rectangle boxes are used for processes. So what do you actually mean by a process? You might be wondering, maybe you might be thinking that a program is a process, but actually process means a part of a program where we do some manipulation to the data that we have. So suppose in this one, suppose we need to add these two numbers, num1 and num2. We need to add those two. So we will put instead of this num1 greater than num2, we are going to add num1 and num2 and then display it. So in that case, what we will do is instead of these diamonds and all, we will put a square in a rectangle box. We will put add num1 and num2. So what that means is we are doing an operation on the data that we have. That's for that we are using those rectangle boxes. So every time you need to include a process such as addition or multiplication or anything like that, something that manipulates the data or something that can change how the data looks like. So things like that, we call it a process, and those processes are enclosed inside this rectangle. And then the last one is called a decision. So for that we use a diamond box. So here if you see, we are actually in this flowchart, we are actually comparing this num1 and num2, and we are checking which one is greater. So here it's written num1 greater than num2. So since it is enclosed in a diamond box, it's actually checking for a certain condition, and the condition here is num1 greater than num2. And this kind of a condition can have only two outcomes. One is that the condition can be true, and the other is that the condition can be false. So these are the only two outcomes that can happen in the case of this greater than checking. So if it happens to be true, the flow will move this way, right? So, since if suppose num1 was 100 and num2 was 50, so then num1 greater than num2 would be true, right? Because 100 is greater than 50. Then we will go this way. This is the flow. Then we won't execute this path. This path won't get used. We will use this way, and then we will display num1. So since it is the bigger of the two, and then we will move on to the stop condition. And if suppose it was the other way around, if num1 was 50 and num2 was 100, then 50 is not less than num2, right? So this condition would evaluate to be false. So what does that mean? Then we do not go through this path, but we take this path, and in this path we will display num2. So there's a certain logic that this thing can give us. So if num2 is greater, we will display num2, and then we will move on to stop. And here you might be seeing this circular junction kind of a thing. So this is used when like here in the case of this condition, the flow is breaking out to two ways, right? But eventually the flow has to reach stop. So at some point these two ways has to intersect, right? So at that intersection or at that junction, we will use this circle. So this circle is used for joining the two flows, and it goes out to stop. So this is some of the fundamental things that we use in flowcharts. There are so many other symbols that we can use, and definitely you need to learn you don't need to learn everything, but it's nice to know at least some of these are the very commonly used symbols in flowcharts. They are really important when you design a flowchart. Every flowchart will have a start and a stop, and most probably an input and an output, and some process or a condition. These four things are will always be there inside a flowchart. So is the topic about flowcharts clear to everyone? Yeah, so it's time for another quiz, I think. So I'll give you a link. So please do try out this quiz as well. So let's see how many responses we get this time. Also, do tell me when you are done. Yeah, the responses are still coming in, so I'll give it a couple of moments. If anyone is left to do it, please do quickly. Okay, so let me finish this poll. So let's see. Right, so really good amount of people have got it right. I'm really happy about that, and I hope you understand what the answer was. If there was any doubt, please do ask me. Even if you got it right or wrong, if you have any doubt regarding flowcharts and these algorithms, please do tell me. We'll be moving on to the next topic now. If you have anything, please do tell in the chat. Okay, I assume there are no doubts. So let's move on to the next thing. Okay, so this is what we are here for, right? So the C programming language. So before we start about C, let me tell you what a programming language actually is. So basically, we humans can communicate using languages, right? We have different languages. Thousands of languages are used by humans, right? So in a similar way, similar to how we use English or Malayalam or Hindi or any language that you know, we need a language so that we can communicate our solution to the computer. We already have some problems, but we need to give the instructions to the computer so that we can achieve that solution. So for that, we need to communicate our solution to the computer, right? So for that, we are using programming languages. So there are a lot of programming languages that are available, such as C, Java, Python, C++, or something else like there are other languages like Kotlin or Dart. There are literally dozens of languages that are available, and all languages have their own purpose. It's not like there's a vast ocean and you can choose any one of them and do everything. Every language has a purpose. It's basically like this. So every language comes with a set of libraries or so-called libraries. So so that some languages are biased to make biased or made for some certain for doing certain operations, certain problems. So C was a programming language that was developed by Dennis Ritchie. That's the person who had developed this language, and it's a really old language. It was released in the year 1972, so it's definitely older than anyone in this meet. I think we are all 2000s kids and all, so this is a really old language, but still it's really popular even to this date. It's a really fundamental programming language, and it's a great language for beginners to start in this world of coding, because it actually diving deep into C, you will be able to understand the internal architecture of a computer system. You will be able to learn how the computer actually interprets these instructions and how it stores information, or how it manipulates the data in a really basic way, in a really easy way. So it goes very deep into the system so that we can understand it really well. we can understand it really thoroughly. And basically, the C programming language was developed in 1972 uh, as a programming language to write operating systems. So I hope all of you know about operating systems. We have different operating systems like Linux, Windows, Mac OS, or even mobile operating systems like Android and iOS. So things like that. So the operating system was the C language was actually intended to be used for writing operating systems, for creating operating systems, but we can actually use it for a variety of purposes. I will show you in the next slide. uh, so the basic idea of C was operating system, and hence we can easily we are able to understand the internal architecture of a computer, because the operating system is a program that's actually closely tied to the hardware and the various firmware that the computer has. So it's a really deep down thing. So you can actually understand a pretty good deal about about how a computer works if you learn C program in a certain high level. So why do you think beginners need to learn this C language? Can someone tell me? Does anybody know why we need to learn C? Why is it friendly for beginners? Why is it said so? Does anybody know? Basically, C is a very fundamental language. So many other languages are actually based on C, or actually somewhat that their syntax, or the look and feel of other programming languages can be similar to C. So it's really easy. If you learn C, it will be really easy for you to move to other programming languages that can be used for other purposes. So C is a very fundamental language that you can start with. Uh, yeah. So and yeah. So let's go on to the applications of C language. So applications of C language include embedded systems. Embedded system. What do you mean by embedded system? So embedded systems. Some of you might have heard about Arduino or Raspberry Pi or things like that. Some kind of a processor, a mini processor, or something like that. So for programming in those kinds of microprocessors and all, we can use C language. Then there and the most important thing is the C language was developed for creating operating systems, right? So that's one of the major uses. And operating systems like Windows, Linux, and all of these, they have some part of them as C, not entirely C, but some portions of these operating systems use the C language. So it's a really important even to this day, even though this was developed in 1972, which is a very long time ago. At that time, most computers didn't even have the specifications that can even closely match today's systems. They were pretty old systems. They were really like this bulky things that you need a whole room to fit in a computer. So from those times when C was developed, it has moved on quite a bit, but still, even in today's world, it's a really significant language to be used. Then we use it for databases such as PostgreSQL, Oracle, MySQL, etc. So what does a database mean? So basically, we may use different kinds of apps, right? We use things like Facebook or Instagram or things like that, various applications. Or so for all of these, there is a server at the back end. So the user doesn't actually need to know what's happening in the background, But the thing is, there's a server inside in the background. So for every website and for every app that you use or anything like that, there will be a database in the backend. So that's where all of the data gets stored, be it the posts you share on Instagram or anything like that. All of that data is stored in a database. So we need to, as a developer of the server, we need to implement some logic inside these databases. We need to sort of the data and store it in a really efficient manner. And there are several other complicated things that we need to do inside a database. So for all of that, we can use some parts of these servers may use the C language, and some other uses include network drivers, compilers, print spoolers, and all. So in these three, I'd like to shift your attention to compilers. So what is a compiler? So I hope everything up to here is clear, right? Now we will move on to compilers and how actually a C program executes. So if there's any doubt regarding things we have done said so far about the C language, please do ask me. Also, you can check out more about the history of C language and other details about it if you search the internet. There's a ton of materials regarding this, lot of articles and all. So you can search that. So are we clear so far with what we have said about the C language and all of these applications of C? Yeah. So next thing is, let's see how a program in C language executes. So okay, so basically we write the code, right? So for every language, we need to write some program or some code. We can actually we use we don't use plain English text as in an algorithm, but we need to there are certain rules that we need to follow in order to write a program, and these rules have to be followed strictly. If you miss one small thing, it can cause an error. So it's a really careful thing that you need to do if you need to write some code. So basically we will use a text editor. So it can text editors like there are some basic text editors like Notepad that you might be familiar with. If you haven't really started into coding, you might be familiar with the Notepad text editor that's available on Windows, or some other text editor that you have on your operating system. So there are lots of other text editors that are really helpful for you to be used as used for coding. So there are coding specific text editors like Sublime Text or VS Code and things like that. You can definitely install some of them in your computers. They'll be really helpful for you moving on. So moving forward, you need some kind of a text editor, and you actually write the whole program inside that text editor. Then what do you need to do so that the program actually works? So if you think in the case of a game that you need to play, there will be an icon inside your desktop, right? So you can just double click that icon and the game will start on its own. But we are actually starting with the basic programming, right? So we don't actually create a graphical user interface right now, right? That's a really complicated thing. There are lots of things that are involved in that. But for a basic program, we can't actually have something like that. Double clicking on that will instantly start executing that program. We need to give that instruction to the computer saying that you need to execute this program right now or something like that, so that the computer can take that code that we had written and then execute it. But it can't just take that code and read it as such, because most of you might have known about this. Computers actually use binary, right? So binary means basically everything inside a computer is a bunch of zeros and ones. It can't read our English language or any other language or anything else. It just knows binary. Binary means 1 and 0. So uh, like so that, but the program that we have written is in binary, because humans aren't actually really efficient in understanding how binary works, right? It's a really complicated thing to do. We can't really write in binary just like that. So what we need is, we need some sort of an interface, so that some sort of a translator in between, so that the translator can actually take this code that we have written and convert it to something that the computer can understand. So that's where these compilers come in. So basically the job of a compiler is to take the source code that you have written, or the thing that you wrote in that text editor, and then take that code and then transform it into something that the computer can understand, while still keeping the task that you intend to do. So it's like a translator. So basically we need a compiler in order to run the code. So once the program gets compiled, the computer can execute that, and it can give us the result. So the compiler works as an intermediate between the programmer and the actual computer. So are we clear with what a compiler does and how actually the programs are written and executed? Are we clear with that? Yep. So I think we can do one more poll as we did a while ago. So I'll share the link again. So that you can keep things alive, right? So here's the link. You can go and start voting right now. So please do vote for this one as well. Okay, good. Keep going. If anyone has yet to do the poll, please do right now. Keep the answers coming in. Okay, so I hope most of you have answered the poll, and I'm going to stop it. Okay. So really good to see almost everyone getting the correct answer. So really happy that you are listening. Thank you so much. So now we will, next up we'll actually look at our first C program. So yeah, so I'll put this link in the chat. You can check it out later. Don't try to you don't have to do this thing right now. But this is basically an online compiler. This 𝘵𝘚.It. So I have put that link in the chat. So 𝘵𝘚.It, it is a online compiler. So basically compiler is also a program, right? So but we need to actually install the compiler on our computer so that we can run things. But for the purposes of this bootcamp, I think this online compiler shall be sufficient. So once you log into 𝘵𝘚.It, you can create your account. It's free. You don't have to pay anything. you can try it out. It's a really good compiler for basic C operations or some other programming languages that you might want to try. There are a lot of languages available in this compiler. So first, when you create your account and all, you'll get this start page, and just clicking this plus will let you start a new program. So since we are learning C, I'm going to take C as the language of choice, and you can give any name to this. So let me actually give it C bootcamp or something. And once you create this thing, it will actually bring up a new page. It's loading. Please bear with me for a moment. Okay, so this is very easy to use environment. Has anybody before used some environments like this before? Can we have it in the chat if you have used such environments for coding? I saw some of you had learned C++ or Python or something. So have you used? Yeah. So some of you might be familiar, but even if you aren't, don't worry. This is a really easy thing to do. This is where you write the code in this file. So this is the main.c file. That's the name of this file, and you can write your code inside this. So the code has to be written in C language. So every code in C language has to be stored using the .c extension. That's how the computer will know that, oh, this is a C file, and I need to execute this in that way, so in a certain way, so that the achieved. So this is our file. You can create other files here using this add file or something, but that won't be necessary for now. And there are various settings and all, but you don't need to bother about that for now. So this is where we write the code, right? And we need to execute that code, right? We need to execute that code and get an output. So for that, there is a terminal here. If you are not familiar with the terminal, it's basically like a command prompt in Windows or a terminal in Linux. So a terminal is where it's the environment where we are actually running the program. Think of it that way. So I already told you, maybe you might play games, or you might use certain applications, and for that there will be an icon that you can click. But in our case, this is all we have. We have just this one file that we can edit, but other than that, there is nothing that we have in our thing. So in order to run this, we need to use this terminal. This is the environment where we can actually call a compiler to compile the program, or to translate that program into machine understandable language, and then run it. So this is basically the setup that we are going to be using. And so this is our first C program. So when you might have observed, I didn't type this in. This was there when I created this new code. So basically, everyone starts with the Hello World program. This is a Hello World program in C. This is our first program. So I'll be explaining every line of this program, and yeah, so I already told you, everyone starts with a Hello World program when they start a new language. So this should be a good start for you. So let's start off with this first line. What does this mean? So there's a hash symbol, there's a text called include, and then inside a pair of angular brackets, it's written stdio.h. So this might seem really complicated, but actually for almost every C program that you do, you would need this line. So the actual working of this line is pretty complicated. We won't be going that deep right now, but the thing is, this thing is required for every C program. So you will be using this on every C program. It's a really important line. If you miss this line, then this program won't work. So basically, what this type of a hash include kind of a line is called is that it's a preprocessor directive. So I don't want to scare you saying these tough words at the beginning, but it's how that C language is made. So preprocessor directive is basically, think of it this way as there might be some pieces, some lines in this code that may use some external code. Think of it that way. And for including those external codes, we are using this hash include. So what are these external codes? So these codes are actually inside a file called stdio.h. This is a file that the compiler knows. This is the file that the compiler has. So basically, in this program, we are telling the compiler that, hey, we need this, we need to include this stdio.h file in our program so that we can execute this thing properly. If you don't give this, then the whole thing will result in an error, because the compiler won't know what to do when the need of this thing arises. So this is the first line of the program, and it's there in every C program. I haven't seen any program that doesn't use this. It will be required in every C program. You just need to know that this thing is used for including a file called stdio.h, and it is a file that the compiler knows, and we will be including it in our program for right now. Then we will move on to this one. So if you observe, this whole part is enclosed in a pair of curly braces, right? Curly braces, these two. So what does this int main void mean? So this is basically a function. Now we can't really dive into functions right now. That's somewhat of an advanced concept in C language, but basically the main function is the thing that gets executed first when the compiler starts running the program. So uh, so the thing is, the computer doesn't know if it needs to start the execution from line 6 or line 4 or line 1. It just gets this data, and it doesn't know where to start, right? So for telling the telling the computer that, hey, you need to start from this line, that's why we use this main function. Main is basically a function. Means function is a set of instructions or a set of statements that can execute and can accomplish a certain task. So here the main function is used because that's the primary function that needs to be executed. So, and this main function should be there in every C program. Without this, the program cannot run, because that's where the computer will start to go and look for, and it will search for where this main function is, and it will start execution from there. So that's the main function. And then inside these curly braces, we can write whatever we want, whatever things that we need to execute. But do keep in mind, we need to follow the rules and regulations that the C language has. If you don't respect those rules, then it will cause an error. You need to specify your instructions, whatever you need to achieve, in a manner that obeys the rules of the C language. So inside this main function, you can write the things that you need to do. So basically what this program does is that when you execute this in this terminal, it will display the message hello world, and that's it. That's just what this program does. It doesn't do anything more. It just prints hello world. That's all. So for printing something in C, we need to use a certain thing called printf. we'll be learning more in detail about printf and all in tomorrow's session. But basically, printf, if you enclose something inside printf, you can print that thing onto the terminal. So here, since we are printing a group of text that says hello world, we need to enclose it inside this two quotations, right? So inside the double quotes, we need to give text. That's how the C language understands that, oh, you are going to use some block of text, some text in English language. So that's how the C language understands, makes the compiler understand that there is something that needs to be output to the console or to the terminal. And then there is this return 0. So what is this return 0? So this is a pretty advanced concept for you right now. This might be a pretty advanced concept for you right now. So basically, this main function has a thing in front of it. It's called int, right? Int stands for integer. So basically, whenever we use a function, we either need to return a value or we need to tell a compiler that we are not returning any value. So this will be a little bit more clear when we go into functions. But the thing you need to understand is, since we have given here int, then we need to return some integer value to the compiler. Think of it that way. So here we have written int. So we are returning a value 0. This 0 has a certain significance, but the thing you need to remember is, if you put int, we need to return something. So return is actually a reserved a keyword. It's a so-called keyword. Keywords are actually words that give the compiler special significance. So this word actually means something to the compiler. The compiler understands that if it encounters such a word, it needs to do this thing. That thing, whatever it is, can be understood by the compiler. So we are returning a value called 0. So basically, for most of the programs, you will be writing, if you are writing int in front of main, then you need to return a value. So that's how this whole program looks like. I hope you understood. Let me just run this program. You can run it using this run button, and it will compile and it will print hello world, right? So that's all that this program does. It doesn't do anything fancy. It just prints hello world. That's it. You can change this text to anything you like. So I can just print hello, and then it will print hello, or I can write, this is the C bootcamp, or something like that. Then it will print, this is a C bootcamp. So whatever you put inside this inside these double quotes will be printed onto the screen. This is basically what this program does. So I hope you understand about this. It can be a little bit complicated, but this is the very basic program that we'll be starting with. If there are any doubts, you can ask me, or if you need me to clarify something, or if you need me to repeat the things that I have said, please do tell me. If it's clear to you, then tell that also. Anyway, please respond in the chat whether you have understood it or not. Yeah, so I think most of you have understood the topics. So that's pretty much what I had intended for today. So thank you for listening so patiently. Thank you for attending. Do come up for tomorrow's and and all of the sessions that are going to be held. So I hope everyone had a good time learning new things. So if there's anything you can ask, or you can try out this 𝘵𝘚𝘀𝑖𝑡 today. You can try out some things, or maybe you can learn something on your own and try out some cool stuff with this thing. And if you get stuck in any point, please do ask it tomorrow. So you can try it out. In it's this site called 𝑟epl.it. So yeah, that's pretty much it. Okay, so see you all tomorrow. Bye bye.
Thank you all for joining. We'll see you all tomorrow.